Welcome everyone to the Lighting Controls Academy's video series. I'm the Lighting Controls Academy's Education Manager, Webster Marsh, and today we're going to be talking about networked wireless lighting controls. This video is broken out into 4 parts. The first part is going over how we define wireless control systems and how they compare to wired systems. The next section is going to cover wireless architecture and how things connect and communicate in a wireless system. Then we're going to look at the system devices that you might see on a wireless lighting control system. And finally, any considerations you might need to think about if you're going to be doing a wireless lighting controls solution. So let's get into it. So the very first thing, defining what wireless control systems are. First, we need to talk about how devices communicate. We need to have some format for communication for lighting behavior. So as we've discussed in previous videos, there needs to be some way of stating what is happening from the user input from a user interface all the way to the light fixture. Wired systems use a communication cable, so either it's 0 to 10 volt, Dolly on a Dolly bus, or DMX through RS-485 cable. Whereas wireless systems communicate through radio waves through the air without any need for a hardwired connection to the devices. Wireless doesn't eliminate all of the wiring in a system because we still need power, and in most cases wireless devices are still going to be using wired power sources. So when we're looking at the difference between a wired or a wireless system, the very first thing that we want to think about is that communication channel and how stable it is. The reason we might want to use wired is because it has that stability and is very resistant to any kinds of interference. But the problem is that it's pretty labor intensive and takes time to install. Wireless, on the other hand, tends to be a bit more flexible, maybe a lower cost, but it has sensitivity to radio frequency conditions or any other scenarios that might interfere with communication or interrupt communication. Wireless is really good for retrofits or remodels, and if you're really trying to add devices to a finished space without having to knock down walls or open up ceilings, they really do provide an excellent solution for that. Whereas it's oftentimes most recommended to consider using hybrid systems where we're combining both wired and wireless devices, oftentimes through a gateway of some kind. So you might have, your corridor is wired together on a wired system, and then you have adjunct spaces like a janitor's closet or back of house space of some kind, a restroom, that you don't necessarily need to have it communicating back to the network the entire time, but you might still want to have that wireless capability, or vice versa. If the corridor is hard to modify, it's an existing corridor, and you just want to add new lighting controls capabilities to the space, and so you might add wireless to that system to be able to give more expanded capability to the lighting in the corridor, but the rest of the building might remain wired for some reason. So thinking through where you're going to be using wires versus where you're going to have a wireless communication is something that's worth keeping in mind as we go through this. When we're talking about wireless, we're oftentimes talking about a radio frequency that's either going to be 2.4 gigahertz or 900 megahertz. A lot of manufacturers vary on exactly which frequency waveband they work on, so it might be worth just asking them which frequency the waveband they work on, and there are pros and cons to either of these wavebands. 2.4 gigahertz tends to share the same airwaves with Wi-Fi and Bluetooth, and so if you're dealing with a saturated space that has a lot of Wi-Fi already in it, it might actually be better to go to a 900 megahertz frequency, or if you know that the space is actually not as intense for its wireless communication, 2.4 gigahertz might be just fine. It really depends on the application. How we are using these frequencies is really how we're sending out data packages. So like any digital communication protocol, we are packaging data in the communications standard that we're using, whether it's Bluetooth, Zigbee, or wireless DMX even. we are taking a little bit of data, packaging it up, and sending it out. And then the device is receiving that package of data, unpacking it, and responding accordingly to that data. As I mentioned before, if we have a lot of RF traffic, so you might see this in certain applications where you have a huge amount of technology going on in a space, or where there's a reason why the airwaves are being intentionally saturated, such as if you're dealing with a security consideration where they don't want wireless communication to be happening in a space and they might intentionally fill the airwaves to avoid having that communication happen. So it's just something to keep in mind, and there are a lot of devices out there that will allow you to monitor and see which frequencies are being saturated and perhaps maybe help you make a decision which frequency might be best. But oftentimes we've seen that most lighting control systems are robust enough that they will still be able to operate within a saturated space. It's just something that you want to keep in mind, monitor, double check with the manufacturer. They might even be able to provide a service where they'll go to the site with you and check those airwaves. But that's where we want to just have proper planning in place. Wireless, in a lot of cases, people say, "Oh, yeah, it's a great, band-aid or last-minute, solution to a lot of our challenges with lighting controls." But actually, it's the other way around. With wireless, you want to do a lot of due diligence and pre-planning to make sure that it's actually going to work on a project, rather than assume that it's going to work and discover later on that it's not going to work. So let's talk about the benefits of wireless systems. So the very first thing that we talk about when we're talking about the benefits of wireless systems is obviously the flexibility. If you have a project where it's just impractical to run wiring for any number of reasons, that is the solution that oftentimes people go to, which is providing a wireless communication capability. So whether it's because it's in a less accessible location, or it's because you're doing a retrofit and you, for instance, are mounting to a surface that you really can't penetrate and run wire to, or it'd be really unattractive to have conduit or just bare wire running around, that's when wireless really comes into play for its flexibility. We additionally are seeing that with a wireless system, you're reducing the control wiring and the labor associated with installing that control wiring. That doesn't mean that all labor immediately goes down, because what you're exchanging for that labor to install wires is labor to program. Now, it's not one-to-one. You're not going to see an equal amount of programming time that's going to be commensurate to the labor to install those wires, but you are still going to see an increase in programming time because of the fact that you still need to address and assign those fixtures that are wireless now. But additionally, because of the fact that it does reduce those physical labor costs, it reduces the physical deployment of the fixtures and the controls. And so in a lot of cases where you have a wireless system, you do see that the implementation of the hardware does happen a lot quicker and a lot more smoothly for the project. And so it really is a benefit to speedier projects that have a short timeline. But also, when you're dealing with late stage changes, if you suddenly realize, oh no, these fixtures are zoned in a different way than I intended them to be, you can do that rezoning rather quickly and easily, similarly to like what would happen with a standard digital hardwired lighting control system like a Dali system. But in this case, it's instead of breaking out a laptop and connecting to the network bus, you might be able to even just break out your phone and change the zoning by standing right near the fixtures. And so furthermore, because of the fact that you're not dedicated to a hard wire connection, it has scalability. And so you can really add or remove devices as you need, or if you have a multi-phased project, you can start off with one phase and then expand on that original phase with new phases later on. And it's not that more difficult, so long as you're within some of the limitations of the system to be able to achieve that. But there are drawbacks to wireless systems. So the first drawback is signal interference, as I mentioned. If you have a lot of radio frequency going on, if you're in a radio studio that's using the same wavelength as you, or again, if you just have a lot of traffic going on for some reason, that is one of the challenges. The other thing is that the range does reduce, so radio frequencies can't go on forever, and in most lighting control systems, they're not designed to go really far distances. They're meant to go rather short distances, and that distance gets shortened if you're going to be going through concrete, metal, or any kind of dense construction material. And oftentimes you even need to be considerate of where you're mounting these devices, because if you mount them right next to an I-beam, you are significantly impeding that device's capability of communicating with the rest of the system, because that I-beam is going to block a rather large portion of communication. There are also considerations when it comes to cybersecurity, and if there's a lot of concern about cybersecurity and hacking, that might be a topic that comes up in discussion. It is important to note that cybersecurity standards do exist, and a lot of the systems nowadays do meet those really strict standards, and as a result, they're pretty robust in comparison to what they used to be. Gone are the days where you would hear about somebody hacking into the building through a networked lighting control system. It's really, there are other systems out there that are actually weaker in comparison to lighting control systems. However, it does just leave the door open a little bit for people to be able to access the network by having wireless communication that can leave the building, so you don't necessarily need to be inside the space to be able to see that network. But there are a lot of considerations that you can keep in mind when cybersecurity is a major concern, so that you can still use a wireless lighting control system without worrying that somebody's going to hack the building through that system. But there's also one last thing that's worth considering, is the fact that if you're doing completely wireless devices where you're using batteries or something, eventually those batteries are going to run out and you need to find a replacement for those batteries. And so planning ahead of time, getting people trained and prepared to be able to do that battery replacement is really critical to the long-term success of the system, because otherwise the devices are just going to stop responding one day and nobody's going to understand why. They're just going to think that the device is broken and that the system no longer works. Finally, there is something to be considered when it comes to heavy network traffic, which is when you are sending tons of signals through the network. So if there are dozens upon dozens of people asking the system to perform certain tasks at the same time, then you might have some latency as a result of that. You're rarely going to see this come up, but it is something to keep in mind, that oftentimes with wired systems, they're a little bit more robust and capable of handling large amounts of traffic in contrast to wireless systems. But oftentimes, again, you rarely see this outside of, for instance, an entertainment situation. So let's go into the architecture of wireless systems. What we mean by architecture with wireless systems is how they are able to communicate and transmit those commands by that radio. So if you're sending an on-off signal, dimming, scene commands, whatever it is, how is that communication working through the system? Simple systems might be a direct point-to-point, and we'll go into what that is in a moment. But oftentimes network systems will share data and coordinate those devices across the different spaces for the purpose similar to a hardwired networked system. The common architectures that we do see with most wireless systems, as I've mentioned above, is point-to-point. We also see star or gateway, and finally mesh. And these are also referred to as topologies, but the reason we're referring to them as architectures right now is because it really does frame how you're going to design the system rather than just at certain points. So a point-to-point architecture, really we're just talking about the direct communication between two devices. Think about like a wireless headset on using Bluetooth connecting to your smartphone. That's what a point-to-point communication. There's no communication out to other devices, and if you want to use a different set of headphones, or if you want to use a Bluetooth speaker, you might have to actually unpair those headphones so that your phone can then pair with another device. Modern Bluetooth allows for more than that, but it still is just a point-to-point communication. You're not actually bouncing around. And so you'll oftentimes see in a point-to-point you have a transmitter and a receiver. Modern technology, you'll see a little bit more than just that, but oftentimes it's in lighting controls, you're seeing you have a keypad on the wall that is communicating to a power pack, and that the keypad is the transmitter and the power pack is the receiver, meaning that the keypad's sending a signal, the power pack is receiving a signal, and that's all the communication that's happening. There's no communication back from the power pack to the keypad because there's no need for that communication. Because of this simple architecture, we don't need additional layers on top of all of this to allow that communication. We just have that point-to-point connection, and that's it. It's really useful for those small, really isolated spaces where we really don't need a whole lot of functionality to provide the lighting controls that we need, but we still have a need for wireless. So again, if you have a small back-of-house space that you just need to add that additional keypad to allow a vacancy sensor to work, maybe point-to-point's the best option for that space because it really doesn't need to communicate out from that space. When we get into Star Gateway architecture, it's similar to hub and spoke in wired, where we're using gateways to communicate between the different devices. So you'll oftentimes have a controller or a user input interface that then communicates out to the network via a hub or a gateway, and then that communication spreads out from that hub or gateway to the devices that are connected to it. If you need to expand the network, you'll need to add more gateways or nodes throughout the project, and gateways oftentimes have a device count and a coverage range, similar to a Wi-Fi gateway or a Wi-Fi router, where you are trying to cover your entire house. Think about that as how a gateway in a lighting control system would work. There's only so far that that gateway can reach before you need to add another gateway. And again, there's a limit to how many devices it can connect to. And so as a result, you might need to add another gateway just because of how many devices you have in a certain space. So just keeping in mind how many gateways do you need to add. And if it's a really large space, you might just have to have additional gateways to cover that amount of distance. With gateways, we often see remote or cloud-based access capabilities. So if you really want to control the space or the lighting from a separate space or over the internet, that is certainly possible. That's not always going to be the case, but it's just something to keep in mind when it comes to these, that gateways can also expand the connectivity capabilities of that system. Mesh architecture is the last one that I'm going to go over. However, there are plenty of other architectures out there. These are the most common ones that you'll see in lighting control systems, but they are by no means the only ones that you'll see. So mesh architecture is where you have every device or most devices in the system acting as transceivers, which is where you're combining both the transmitter and the receiver into one device, which means they can send and receive data as well as relay data, repeat it throughout the system. And so you'll have multiple communication paths throughout the system, making it a little bit more resilient, which can oftentimes be described as a self-healing network, because if one node goes down, other nodes will pick up the missing link between the system to allow that communication to permeate. The way I liken this is if you have a loudspeaker and you're talking to a large crowd of people, but not everybody can hear you, so you shout somebody's name and that person doesn't hear you, but everybody else in the crowd starts repeating whatever you just said until it reaches the person who can finally hear it because of everybody else repeating the information. That's kind of how a mesh architecture works when it is a self-healing architecture. So if one person in that crowd disappeared, that message would still be able to permeate throughout the entire crowd. Because of this format, it really does work best when it's a big cluster rather than a long string of devices. So instead of, thinking of it as like hopping, it really is just sort of like permeating throughout the space. And so the more devices you have in a space, the more robust the communication becomes. All right, so let's talk about what devices we might see. And we've already mentioned a couple of them, but there are a lot of different devices that you might come into contact with a wireless system. So when we're talking about wireless devices that you might come into contact with, it's really important to think about, what the common controls network is going to be and how that hardware interacts with the system. So examples of devices you might see are remotes, apps, controllers, integrated controllers, servers, gateways, interfaces. All of these are terms that we'll go over in a moment. But just like we talked about with the gateways, there are going to be device counts and ranges to each wireless device. Some devices, like in a mesh system, still have a device count, but they seem to be a little bit more broader in how many devices it can connect to, but the range tends to be a bit narrower at the end of it. So ultimately, how you apply the wireless system, what kinds of projects, that's where it really comes into question of when you're going to be using which devices and how you're going to be using them. And so the other thing to keep in mind, just like with RF frequency interference, we want to make sure that we're planning device distribution early so that we're making sure that we have enough coverage. Again, if it's a mesh system, the mesh devices typically have a bit narrower of a coverage area, and if you're going to be leaping across large gaps, you might need to provide devices in between those gaps to help make sure that there's enough coverage to allow the entire network to communicate together. Also, to keep in mind when we're talking about devices, how you configure those devices. Sometimes a lighting controls manufacturer might provide a remote configuration tool, oftentimes in a remote format. And what it does is it's used to help set up the system or start up the system. It might use Bluetooth or Wi-Fi or even infrared to communicate wirelessly to the devices. If it is infrared, however, oftentimes you can be dealing with a line of sight situation. So if you're trying to program a lot of devices with infrared, that might actually be a slower process than if you use Bluetooth or Wi-Fi. It is useful to think about these as quick configuration tools for the purpose of starting up the system. They are not meant to be ongoing devices to use all the time. They're just meant to get the wireless system going, and then there might be other tools out there to help continue to use the system, such as an app. So apps oftentimes run off of phones nowadays, although you might see tablets or laptops being used to help with this. And they'll usually connect directly through the communication protocol that they've implemented, but sometimes you might see them using a different technology or even indirectly through a cloud-based system. These are also used as ways of setting up programming or even updating the firmware on the system, but they really do vary by manufacturer, and so as a result, you might have the app used every single day, unlike a remote configuration tool. Apps have a lot of capabilities based on which manufacturer provides them, so getting familiar with how the apps work is a really handy way to get familiar with how the system works. And a lot of manufacturers are more than happy to show you how their apps work, give you training, so that you understand the system a little bit more. So just like with any lighting control system, we want to start with the controller, which is the device that is going to take in those inputs and decide what is going to happen with the lighting and change the lighting based on those inputs. That's what the controller is there for. It might be based on the wireless communication method or the architecture. So in a point-to-point, the controller might actually be the same thing as another device, but we still need to identify what is the controller in the system. Oftentimes, controllers are still going to need wired power of some kind, whether it's line voltage or low voltage. And so oftentimes you'll see controllers either with the line voltage power running to the fixture or attached to the fixture's power source. And so when we're really dealing with the controllers, we're trying to coordinate it with keeping in mind the sensors, the switches, and the luminaires outputs. And oftentimes you need these controllers to be within range of all of these devices, especially in a mesh system. But if you have a hub and spoke or gateway system, you might be able to get the controllers a little bit further away from these devices. It really depends on the architecture and the design of the system. Servers are the next thing that are worth considering for a wireless system because they expand the capabilities of the system. So they might add the ability to do analytics, do some data reporting, maybe even give you access to the project from further away or via the internet. They can be on premises, although oftentimes nowadays we're seeing more and more that cloud-based servers are being utilized for network lighting controls, and especially when we're dealing with wireless. So oftentimes we'll see a recommendation to connect the lighting control system to the internet. However, it's good to keep in mind that if a server goes down, modern systems oftentimes don't stop working without that connection. Most lighting control systems are designed to just keep operating as though nothing happened, because the server really is more about collecting data and giving reporting, maybe distributing new information to the system, like if you're changing configuration or you're updating presets. So really the devices in the network typically store some data and continue to operate without a server. But the server features really do add in those additional layers, and we're seeing more and more with requirements from larger agencies that are saying you need to have some way of reporting how much energy you're using in a system. And so as a result, having a server might be a requirement based on the jurisdiction you're working in. Gateways, as I've mentioned, they tend to expand the system's capabilities, but they also oftentimes will be a connection to a cloud or server capable device. And so gateways might even add in that ability to connect to the internet. And without a gateway, you might not be able to connect your system to the internet. They oftentimes function a lot like wireless routers, but tend to not be necessary, especially in a mesh-based system. But additionally, if you want to integrate with the building's IT network or even with other systems like HVAC, you'll oftentimes see gateways being utilized for that purpose so that you can actually translate your wireless signal to a wired signal that will connect to the building. Again, we need to think about cybersecurity requirements when we are talking about connecting devices to the internet. So when not all systems need to connect to the internet, and in fact, most systems don't need to connect to the internet. And so as a result, we want to keep in mind when we're connecting to the internet and what we're doing with that connection to the internet. So you don't necessarily need to connect every single wireless lighting control system to the internet. And so just something to keep in mind that, again, if cybersecurity is a big consideration, maybe you just don't connect it at all to any internet or building IT infrastructure. System interfaces. So interfaces are just devices that expand the range and capacity of the system. So you might see with hubs or bridges, repeaters, you might hear the term node or area controller. These are just devices that expand the capability of the system. And the terminology really, unfortunately, varies by brand, but again, these devices are just auxiliary devices meant to help with that communication. Especially in mesh systems, you might need to add a repeater where you have a large gap between spaces. So these are the devices that are meant to help smooth that over. But the other thing is that they might be used if you have that bottleneck consideration where you have a lot of traffic going on. You might be able to use a system interface to reduce how much traffic is flowing through one single device. Power sources. So with power sources, most of the time you're going to see line voltage powered devices in a lighting control system at some point. It's either going to be a gateway or some other kind of device that just needs that dedicated source of power. It is technically going to be changing that power to a low voltage DC power, but usually it's designed to take in line voltage and it will do the conversion on its own. Whereas other devices will use batteries, as I've mentioned before. There are a lot of devices in a wireless system that might be able to use a battery source as opposed to a line voltage power. And you often see that that batteries are rated for a pretty long lifespan, such as 10 years, which is a decent amount of time, and usually that's an average based on heavy use. So if you don't really use your keypads or your sensors very often, that lifespan might actually extend further beyond 10 years. But then if you really are conscious of how much maintenance that device needs, and if that device is not easy to get power to, you might consider energy harvesting, which is where it might use photovoltaic or daylight or just light in general to power some cells inside of it and operate off of the ambient light in the space. Or there are switches out there that use the kinetic power of you just pushing the switch to power itself. Oftentimes you'll see energy harvesting with limited capabilities, very simple command structures, but there are devices out there that use energy harvesting as a solution. But it's really important to think through what you are doing, how it's being applied. So not every project should use energy harvesting. Not every project should use batteries, nor should you have line voltage powered devices for every single project. You're oftentimes going to either see a mixture of these, or depending on the project's needs, you might have to pick one that really adheres to the project's needs. So getting into the solutions that we need to think about for wireless lighting controls, the very first thing is protocols. And I've talked about protocols in previous videos. When we're talking about wireless protocols, it's very similar thought process in the sense that each protocol has its benefit, each protocol has its drawback. But when we're talking about protocols in general, if you haven't really heard this term used a lot, it's the way that we define the rules for communication and interoperability. There are a lot of different versions out there, and especially when we're talking about protocols such as Bluetooth. Bluetooth has a wide range of options out there, and they're not all directly compatible with each other. The Bluetooth that you use to connect to your headphones is not going to be the same Bluetooth that the wireless mesh devices are using to communicate with each other. There are gateways out there that are able to translate between the different protocols that are existent, including between wireless and wired networks. So in something you might interact with on a regular basis, a wireless router in your home is technically translating from a wired Ethernet signal to a wireless Wi-Fi signal. Those two are not directly compatible, and so that is a gateway as well as a system interface to communicate out to your Wi-Fi signals. How you select your protocol really could have an impact on how the design of the system is, how scalable that system is. And so keeping in mind, again, why you're picking a specific protocol, it might be a more difficult task than you might think. A lot of people might gravitate towards Bluetooth Mesh, for example, but Bluetooth Mesh is not applicable to every single project out there. So it's important to just keep in mind the considerations that we've gone over already. But let's go into the common wireless protocols that we've seen in most lighting control systems. The very first thing is Bluetooth, or in some cases Bluetooth Low Energy, and most networked lighting control systems nowadays do use what's referred to as Bluetooth Low Energy or Bluetooth Mesh, although again there are a variety of different Bluetooth versions out there, and again they're not all compatible with each other. So, but what we've seen with Bluetooth is that especially Bluetooth Low Energy, is that it is a low power, low demand communication protocol. And so we oftentimes see it with configuration and application control for systems in a lighting controls application. Whereas Bluetooth Mesh, Zigbee, or Thread, these are all very similar communication protocols using a mesh communication capability. So in comparison to Bluetooth Low Energy, which is meant for point-to-point communication, Bluetooth Mesh we're going to see more for that networked communication capability, and Zigbee and Thread operate similarly as mesh networks. Wi-Fi, on the other hand, is a very high bandwidth, high power, typically IT dependent communication protocol. So unlike Bluetooth Low Energy, which is really a low power, low consuming solution, but really meant for that point-to-point communication, Wi-Fi is going to be very power hungry, and so you'll oftentimes see Wi-Fi gateways or system interfaces using line voltage converted to DC power, as opposed to Bluetooth Low Energy, which might use just a small battery to power itself for a very long time. EnOcean is another example of a very low power solution. It's actually less power consuming than Bluetooth Low Energy, but it is also a very simplistic communication protocol. You'll oftentimes see EnOcean devices are the ones that use energy harvesting capabilities because of how low power it is, but because of that, again, it's a very limited communication capability, and oftentimes you'll see EnOcean used in either point-to-point or very limited repeating communication packets. LoRaWAN is a really good long-range, long-distance communication protocol, and so you'll oftentimes see this for exterior or interbuilding communication capabilities. But it is also another great resource to tap into, and you might see that a lot of systems will actually implement multiple versions of these. In some cases, you might have Bluetooth Low Energy for that app communication to the system to be able to do that configuration, but it'll use Bluetooth Mesh to communicate from device to device. It might use Wi-Fi to then connect to the internet, and you may even have EnOcean devices in that same system for those energy harvesting capabilities. So it's not that the system will always be the same protocol. You might actually be changing from protocol to protocol. But there's also something else that just needs to be kept in mind, is that there are systems, especially in the United States, that use proprietary versions of radio frequency. They may even be called Bluetooth, but the way that they have encoded the data is that it makes it a proprietary communication, so you cannot connect one Bluetooth system to another Bluetooth system. Now, there are open standards out there, such as Bluetooth NLC, which is intended to be a standardized open standard for multiple manufacturers to utilize, or Thread is another example of that. But in the United States, again, we still see a lot of proprietary, similar to a wired system, where you're locked to that manufacturer. Now, there are pros and cons to why you would use a proprietary radio frequency. There is a lot of guarantee with functionality in proprietary, whereas with open standards, there is a little bit more fluidity. So there's always considerations. There's pros and cons to every choice when it comes to protocols. The other thing to keep in mind, as I've mentioned before, is the wireless signal range. So range really is affected by how far away or how many obstructions there are. You might have concrete or metal, and this is where you might see a lot of devices will say do not mount inside of a metal enclosure, because that will actually completely block off communication outside of that metal enclosure. So you'll see either an antenna attached to that box or a plastic fake panel so that communication can still leave the box. It's not trapped in that metal forever. But there are a lot of guidelines out there when it comes to how you want to mount stuff, where you want to mount stuff, how far away things are. Manufacturers are more than happy to help walk you through what the project might need for communication. And one of the nice things about wireless is if communications is a little bit flimsy and you didn't realize it, you might need to add another gateway, but adding another gateway might not be as significant of a cost to be able to do that. So it's something that's really nice about the flexibility of the wireless lighting control systems. But again, always verify with the manufacturer, and field testing is always a good option. I oftentimes recommend that people do a mock-up just to see if the system's actually going to function as intended in the space. The other thing to keep in mind is that there's a lot of interest in what's referred to as luminaire level lighting controls, or LLLC, or as I refer to it as triple LC. What this is where we're adding a node, wireless controller, and a wireless transceiver to each light fixture. And in some cases, and depending on which definition of triple LC you follow, there might even be a sensor added to that so that the entire luminaire is independently controllable, independently detecting its own traffic, its own light, its own movement around it, so that even if for some reason communication were to fail, that fixture is still able to operate as though nothing has happened. These systems can be really quite complex, but the benefit of having TripleLC really does improve that granularity and energy performance of your system, because all fixtures have that visibility of how occupied the space is, how much daylight there is. You don't run into the same issues as if you had just a single motion sensor or a single daylight sensor in the space. So having TripleLC really does expand capabilities and improve the functionality of the system. And in some cases, it's arguably easier to install these because you no longer have remote devices to the fixtures. There are a lot of considerations for TripleLC, although including having auxiliary power, which oftentimes is dependent on the driver. And in most cases, standard 0 to 10 volt drivers will not have that auxiliary power. So it's important as a specifier to make sure that the light fixture actually has the correct driver to be able to provide a TripleLC application, because not all TripleLC controllers are provided by the same manufacturer of the light fixture. It might be done through OEM, original equipment manufacturing, which means that the manufacturer of the sensor or the TripleLC module will ship that device to the light fixture manufacturer, and the light fixture manufacturer will install that device. Or it might be field installed, meaning that the light fixture manufacturer sends the fixture to the site, the lighting controls manufacturer sends the module to the site, and the contractor will install that device in the fixture. And it's the second one that really could run into issues if it's not carefully planned out and that auxiliary power source hasn't been provided. The drivers might have to be swapped out, or the entire fixture might have to be swapped out, and that would be a very costly change in the project. When we're designing a wireless lighting control system, the process is the same as we've discussed in the 3-part How to Design a Lighting Control System video series. First, we're going to start with the OPR, the control intent narrative, and the sequence of operations. We want to make sure that it's clearly outlined what is expected of the system's performance before we get into any system design whatsoever. When we get to the actual design of the system, we're going to go over all of the requirements that might need to be considered. What are the signal range and paths for the communication? How many devices can we actually add to a specific node, specific gateway, or to a mesh area? What kinds of architectures are we using? Is it going to be point-to-point? Is it going to be star, or is it going to be mesh? What kinds of protocols are we using? Are we having different protocols in the system, or is it all the same exact version of that protocol that we're implementing in the system? What kinds of power sources are we using? So are we using line voltage converted to DC? Are we using battery power, or are we harvesting the energy, or is there a completely different energy source that I haven't mentioned in this? It's important to just think through how you're powering these things, and maybe even where the power source is getting mounted if it is a remote device to the device that you're trying to power. Additionally, whether you need a gateway or server to expand the system's capabilities to meet the needs of the system, such as if you need to have a dashboard reporting how much energy you're using, or if you need to connect it to the internet. What other installation constraints are there? Wireless is not going to be able to install to every single space. If you have a giant concrete building with lots of narrow corridors, mesh is probably not going to be the best option. In fact, I wouldn't even recommend a wireless solution in that case. However, it's still possible. It's just going to take a lot of careful planning to do. So thinking through what is the project's space and how are you installing all the devices in that space. And then finally, how you're starting up the system and programming it. If you need wireless internet, or if you need to connect to the internet, making sure that the internet is actually active on the site before the programming happens is really critical. There are a lot of times where a technician will show up to a project and the internet's not ready and they can't do the startup that they need to do because they needed that access to the internet. So that's pretty much it when it comes to wireless lighting controls from a high level. There's a whole lot of other things that's worth considering when it comes to wireless, but at the end of the day, wireless lighting controls systems are a great solution for a lot of different projects out there. It's important, though, to just keep in mind your radio frequency limits and whether you have radio frequencies saturating the airwave, what kind of protocol you might need to use for the lighting control system that you're trying to implement, how many devices you're going to be using and where they're going to be distributed, as well as just making sure that you've gone to the site if it's existing and talked to the manufacturer to make sure that there's no additional considerations that you might need to think about when it comes to this lighting control system. But really the biggest thing is always use the same fundamentals that you're using for a wired lighting control system, and you're oftentimes going to see that the success of the project really does boil down to, have you talked about what the expectations for the system's functionality are, and are you actually going to be able to achieve those functionalities and what the owner expects from the system. I'm Webster Marsh, the Education Manager for the Lighting Controls Academy. I hope you enjoyed this video. Thank you for joining me, and hopefully I'll see you in the next one. Before you go, a quick word about who we are. For over 25 years, the Lighting Controls Academy has served as the voice of the lighting controls industry. As a coalition of the National Electrical Manufacturers Association, or NEMA, we were created to help educate the public on lighting controls technology and real-world applications. Our hallmark program is our online education, including this video series, along with written courses through NEMA Academy. If you want to keep learning about lighting controls, head to lightingcontrolsacademy.org. You'll find articles, industry news, new products, award-winning projects featuring controls, and plenty of other helpful resources. Thanks so much for watching, and hopefully we'll see you in the next one.